Let's work on this problem that involves z-score. So first of all, let's try to make sense of z-score. So geometrically speaking, what is a z-score? Z-score measures the relative standing of a given value. So if this is your mean, usually we call it mu or x-bar, depending on whether you're talking about sample or population. So let's just label that. You use one of those, say mu, mean. When you have a z-score equals -1, that means the value you're talking about is one standard deviation below the mean. So this will be mu minus the one standard deviation, which is sigma. So in this case, z is -1. When you have a value that is 2 standard deviation below the mean, which means mu minus twice of the standard deviation, then you're talking about z-score equals -2. And similarly, if you're on the other side, suppose this is 1 standard deviation above the mean, then z-score will be 1, and if this is 2 standard deviation above the mean, the z-score will be 2. And you can kind of hopefully you're convinced by just looking at the formula. If you can recall the z-score, how do we compute z-score? The value minus the mean divided by the standard deviation. So if you have this value, say mu minus sigma, I'm gonna say the value is mu minus sigma. So minus the mean. What is mean? Mean is mu, right? Divided by sigma, and you can see that mu and mu cancel, and then you're left with negative sigma over sigma, which is -1. So I just want to use this example to convince you when you have 1 standard deviation below the mean, that means z-score is -1, and so on and so forth. Okay, now time to take a look at this problem here. We do know that mean of weight is given by this number, and the standard deviation is this number. And the question is asking what weights are significantly low. In other words, we need to find a weight whose z-score is corresponding to the corresponding to this point, z equals -2, right? Which means the value you're looking for should be mu minus twice of the standard deviation. So this would be how I would solve this problem. So 5.67243 minus twice of the standard deviation, which is 0.05856, and then after the algebra, when you do this algebra, that would be the number that you want to fill in here. So any value that is lower than this particular number, I'm skipping the algebra now. So those values would be considered significantly low. So this is how I would solve this problem.